Is everyone ready to get started? All right. Thank you very much. Could I ask Bill Ray to come up, please, so I can embarrass him? Okay. So we had really supportive agencies in this case because we were doing research, but even so, it's very difficult and onerous process to get the permits. And there was no one on our team that had the expertise to get it done. And Bill Ray from Port of Tacoma volunteered to do it on nights and weekends. And I think he just deserves a special appreciation from everybody. Now, if you know Bill, all you have to do is buy him a beer and he'll do anything. But we decided to go a little bit further and get him some gear here to help him in his job as a biologist down at the port. So thank you very much. Okay, so we had some really good questions come in from the webcast. So why don't I start with a few of those. Some of you may leave during the hour. It's okay. If so, please complete your surveys. That'll help us design the Vashon Island test. And same for those of you on the webcast. Just there's a link for you to complete the survey as well. We really appreciate it. Okay, so let's start here. All right, this question is coming in from the Netherlands, from TNO. What are the limitations on pile diameter? Could this be used in offshore wind turbine foundations, for example? Maybe, Per, that's close to where you grew up. Maybe you should take that.
That's right. In principle, I don't see any limitation with size. The practical limitation is the size of the hammer itself. You know, for vibratory driving, you couple several drivers together and drive those things in, and if you know the diameter could be 5 meters or so, or more.
Okay. And another question also while we're talking about size, this came in from U.S. Department of Transportation. Is there a limitation on pile length? Tim?
I don't see any limitation whatsoever on pile length.
Okay, and then a second follow-up question. Is there a ratio required between the inner and outer pile diameters for this to work? So what does the space need to be?
The space between the inner and outer piles is determined primarily on pile straightness. As you can imagine, if you had a really, really long piles and they weren't quite straight, you would need to have that space be larger so that you can accommodate the relatively crooked inner pipe. So as long as we're using straight materials, we can minimize that gap. Just has to have air in it, that's all.
Okay. Let's take a question from the group here. Yes, Marion Carey.
Follow up on the pile length question. So this is a follow up on the pile length question. I wanted to ask Bradley about the difficulty in handling longer piles when you're dealing with the double wall pile. Do you see any difficulty in having to add segments in the field?
If it was in a splicing scenario, no. If it's a mandrel-driven pile, it's got some trickiness to it because you're kind of getting into a scenario where you might have multiple mandrels, one for a longer application, and you know, so you start your bottom in with a shorter one and then increase. So.
Okay. Question for Jim Laughlin. You had in your presentation that this could potentially eliminate the need for vibratory driving. The question is, why is this potentially better than vibratory driving?
Well, if we eliminate that step, typically what we do now is we vibe first to minimize the exposure of sound to the species in the water, and then we'll impact drive for a shorter period of time. If we eliminate that step, it's a cost savings. But then there are other issues of it could be a longer drive, which would increase the cumulative SEL and exposure to the species. So it's a trade-off in some ways.
Okay. Question from British Columbia here. Can double wall piles be installed using a vibratory hammer? Per?
So far, we've focused on impact driving, and that we haven't looked at that issue. So it's up in the air right now.
Okay.
When we removed the ones that we did, they were intact when we removed them, so I don't know. It hasn't been dried.
Okay. Questions from the audience? Yes, gentleman from the Navy.
Has there been a, I guess, Dave, this is for you, has there been a comprehensive cost analysis really done to say, we have cost savings here, we have fewer observers, but the piles are more expensive? Anybody's really looking at, we expect the per pile cost in 5 years to be higher, lower, or about the same?
The question was whether we've done a comprehensive cost analysis looking at the entirety of a project, and the answer is not yet. We do have a model, and what it looks at is the pile cost versus the savings that can be gained from streamlined permitting, faster pile driving, fewer interruptions. So we'd have to look at each individual project, the dimensions of the pile, the wall thicknesses to get the right material cost, and then contrast that with the potential savings from streamlining everything. And so we'll learn a lot more when we do this on a larger scale project and not just a test. Yes, John Stadler.
So, just folks, just full disclosure here.
Maybe I should give you the mic. A lot of people want to hear what you have to say.
Then everybody will know. So, I'm John Sadler. I'm with the National Marine Fisheries Service, and we've been working with WashDOT for many years on pile driving issues, and I'm really thrilled with what they're doing here, and they deserve a lot of credit. They're doing things that other state DOTs probably want to do but haven't been able to. But so the question comes up, will this eliminate the need to use a vibratory hammer to set the piles, to drive them as deep as you can first? And ideally, that would be what we would want out of this, but so far it's an N of 1 on, one size pile. We know that different size piles, when they're just driven the traditional way with an impact hammer, will produce different noise levels. Larger the pile, generally the higher the noise level. And if this, if we had some confidence that that attenuation, 17, 18 on the SEL and the 21, 23 on the peak, that would go a long ways towards getting us to be comfortable to doing that. But I understand this is a very expensive process. Talking to Marion, it's mind-blowingly expensive. But are there ways that perhaps Peter or Per, you could model the different pile sizes to give us some idea of the attenuation that you would get from the different size piles, and see if there's a consistency across them, so we could have one number that we apply, or if it varies depending on the size of the pile?
I haven't looked at larger piles yet, but for me, seeing this agreement between the model and the scale test and the 30-inch test, I mean, it's a very good agreement. So I have pretty high confidence that we can use the model to predict the larger size piles. And so that will definitely be done.
And just to clarify, it's not our expectation that the piles themselves will be breathtakingly expensive. It's just conducting a test is breathtakingly expensive, like the one that we did. So that's one of the reasons we really want to get this next test right, the one on Vashon, and get all of the questions answered from throughout the community, from the agencies, contractors, you name it. Okay. All right, other questions? Yes.
And I believe I heard this during the presentation, that you haven't done any testing at all in terms of counting it to the degree of load-bearing capacity. Because to me, that just seems essential, and that's what a lot of regulatory agencies are going to wonder about, is when you really start doing the hard pile driving, then what happens to the noise?
Yeah, so the question is, why didn't we do any load-bearing testing? And I guess I would follow on and say, what are our expectations for how the piles will perform in harder sediment or glacial till?
I'm pretty confident about our ability to penetrate hard sediments, because if you look at the construction, you hit the top of the inner pile, and the path, the structural path, is straight down to the shoe, and there's a rigid connection between the inner pile and the shoe. So it should behave well in hard soil. And the question for us was more how does it behave in high friction environments, and that we tested in Tacoma.
And you don't think there'll be any really bump up in the noise levels going through that?
It remains to be seen, but personally, I don't think so. But we'll see. We'll see when we test.
The question that, again, just for the webcast folks, the pair just responded to the question, do we expect the noise levels to increase when we encounter harder soil?
I think if I could just follow up, I mean,
Please.
you would expect if you drove a control pile through harder soil, you would get a higher noise level. What we wouldn't expect would be the difference in the reduction in noise to change as a function of entering that glacial. But you might, in fact, get a higher mitigated noise level just because the overall noise level was, in fact, higher.
The question for you, Peter, how would you compare the rigor of the acoustics measurements done in this test versus sort of a typical industrial situation?
Well, this was much more complete. For sure, in an industrial monitoring situation, you wouldn't have the multiplicity of hydrophones out there. That said, it wasn't perfect. There are rooms for improvement. I have some ideas on where would one go to get that. The field is very, very complicated, and if you have a situation where you're trying to measure this field and you have a before and after, and you found out all the sound came through the kitchen door, and you got great, but then all of a sudden you saw something go through the kitchen window, you have to have a hydrophone there. My point being, you have to really have a large spatial distribution of hydrophones, probably set out a little bit further than what we did.
Okay.
So, and that would I think probably answer some of those questions that might have emerged today.
Okay. It's a question from Mike Holloway. Tim, can you elaborate on the force transfer detail from the inner pipe to the pile toe?
Sure, I can try. So in the talk, I showed you guys a cross-section view of what the pile toe or pile shoe looks like, and we made reference to a flexible coupling between the inner and outer pile, and I made reference to it as being called a spring, and you can think of it as a compression spring, such that when the impact hammer strikes the top of the pile, that sends that inner pile downward. As it moves downward, it compresses that spring, and as that spring compresses, load is transferred from the top of the spring through the spring to the bottom of the spring and then into that outer pile. So as the inner pipe goes down into the dirt, the load is transferred through the spring and pulls the outer pile with it. Because it is a compression spring, if you run into a really high skin friction environment with virtually no bearing, that spring will get compressed to its maximum amount, and then there's no more flexible in that coupling because the springs collapse, and then it's just a rigid connection. So hopefully that addresses the question.
Does it become steel on steel then?
It will still always be steel on rubber, but it will be a solid piece of rubber as opposed to non-solid piece of rubber.
Kind of a similar question here from Jason at Hart Krauser. Given that the outer pile is being pulled by the inner pile, can you foresee a soil situation where skin friction might exceed coupling force?
The answer is no. We thought about that, and that's the reason why we went with this said compression spring, because in an instance where you have extremely high skin friction, low bearing, that spring gets compressed all the way, and then you have no more ability for the inner pipe to travel without a direct load being transferred to the outer pipe. So it has to go down. There's no other option.
Yes.
I guess I was gonna ask about that. Is there a potential for that material to extrude up through any kind of gaps? We've had bridge bearings with rubbery type material where that's happened.
The question is there the potential for material to come up through the gaps in the shoe mechanism?
Do you want to field that, or do you want me to?
Yeah, go ahead.
Okay. There's always a potential for something to happen. However, in the design, we considered that exact scenario, and we designed the steel to capture the rubber such to minimize the possibility of it extruding through that gap.
Dave, I have a question.
smaller, heavier walled inner pipe to create, does that help the noise attenuation if there's more space between the two piles inside? Is that been a consideration?
The question was, did we look at a smaller diameter, thicker walled inner pipe and then creating more space, interstitial space between the inner and outer diameter to help with drivability and noise attenuation?
We looked at that, but the configuration that we have, it's almost a perfect shield, you know, going from the inside to outside. So very, very little sound or noise goes through the air gap. So that's not the problem. So the noise that we get from the double pile is through the, from the shoe out.
Yes, oh, good, here.
Are you testing the same pile diameters at Vashon, or will there be variability?
We're actually testing the exact same piles at Vashon. We pulled them out of the site at Commencement Bay, and they're going to be redriven at Vashon Island. So there'll be zero variability in the amount in the pile itself. Only changes the equipment and the soil conditions.
If additional funding arrives magically, then we do bigger piles.
Okay.
What's
Right answer.
Well, I just have to repeat it if you don't use the mic.
What's the feasibility of using this process at a remote location where the piles might have to be assembled on site? Like a lake.
It's the same. We trucked all of the pieces in 40 feet and under. It would be typical. If you are in a remote location and you can get a steer car, you can get 140-foot piles. It just depends on what your access is, but you can bring them in small and build a bed on site and weld them up.
Another question that came in is, why do you think we got slightly better results with the mandrel pile versus the double wall configuration, the standard double wall?
I think it's because we had, N was one. I mean, we had one pile, one type, and then another type, and they were driven at slightly different locations. So I think if you have 10 of each, then it will average out. You know, acoustically, they should have the same performance.
And Tim, what would be the situations where you would use the plain double wall versus the mandrel versus the concrete filled double wall?
Well, as you alluded to earlier, we have a model that looks at the value of time versus the value of capital equipment or operating costs and the material. And so in certain instances, one could imagine that getting the project done fast saves the most project cost. And in that case, we believe that economics are going to steer you towards using a double wall pile or a filled double wall pile, simply because you don't have the time to handle the mandrel. However, in other instances, you can imagine where you have a lot of time, but you want to minimize your material costs. And to minimize your material costs, we believe the mandrel double pile, at least at this point in time, is going to get you to a minimum material that stays in the ground and is part of the permanent structure. So it's all about the time versus material, really. Does that answer your question, Dave?
It does. Here.
So my question is kind of on the handling thing. I'm making the assumption that the mandrel is only going to be practical to a certain reasonable length. I mean, you can only handle like probably an 80 or 90-foot mandrel before your leads get. Can you speak a little bit about where you would see the practical length for the mandrel where you'd have to go to the double?
During extraction of the mandrel, you could foreseeably become height constrained with your boom height, right? So I think it's really crane to crane before you can answer what that true mandrel length is, and it's all about pulling that mandrel out of a final installed pile. We do have the mandrel designed. You only saw one segment. That's all that we had at the test. However, what we have designed is a multi-segment mandrel so that it can be additional length can be attached to the top as needed when you splice. And so then what you do when you would remove the mandrel, you wouldn't be able to pull the whole thing out because now you've made it hundreds of feet long. So what we have a mechanism that you can pull the mandrel out, hold the pile or hold the mandrel in place, and then remove the coupling between the mandrel sections, take the top section, put it back on your material barge, then you can come back and grab the rest of the mandrel and extract it. And that was it for time. I just couldn't show you all that detail today.
You could,
Coupling,
Oh,
you look at putting a coupling together.
very, yeah,
For the mandrel,
like
right.
they would splice a concrete pile, for instance.
you could do some longer mandrels than the hammer and leads actually fit on, because you're losing depth in the longer mandrel. You've already driven the bottom. So I think without any change, you probably could drive 120 to 140 foot. If you get into longer than that, it gets complicated, and the mandrel would have to go essentially taller or higher than your boom tip, so you're grabbing it lower. It's just really complicated, and it can be done, but it's tricky.
I'd like to congratulate my purple and gold friend from across the mountains. I wear crimson and gray, but that's okay. What's happening here from a mechanical engineering standpoint is amazing, so I congratulate you guys. And if something bad happens in the room today, not very good, because we're going to be set back 10 years by what these guys know. So congratulations also, Tim, on your upcoming degree here. And Tim, I think this question is for you. And my question comes from the practitioner standpoint. When we're out there banging piles in, how do the people observing and the regulators know that we haven't failed something like the seal at the bottom, or we didn't get the weld right and things aren't perfect? How reliable is this new technology going to be as far as the pile driving company is concerned? Can they just bang them in there and we're going to get 20 dB? Or do I have to worry about, oh, the bubble curtain didn't go all the way to the bottom? It's useless today. Any thoughts on that, or do we have to practice?
Yeah, let me just repeat for the webcast. So after some really nice comments for the inventors, the question was, how do we ensure reliability in the field?
So yeah, I have a couple thoughts, and then I'm going to ask the rest of the panel to weigh in as well. First thing is we talked about that our sample size so far is one. So with one sample size, it's really hard to make a comment on long-term durability other than the materials that we use are well recognized. We know their properties. We know how to design using run-of-the-mill rubbers and steels. So it's not new to a mechanical engineer. So I have high confidence, but I can't prove to you what the reliability is. In terms of how do we know if a seal broke or something happened, we instrumented these test piles in one way to monitor that by using a method to determine if water had got into that annulus that we talked about earlier today. And then the other thing that immediately comes to mind is the real-time acoustic monitoring system that Professor Dahl and Jim spoke of earlier in the day. That could be utilized to know if something erroneous happened during the pile driving process, where suddenly it went from quiet to loud. And maybe these guys have some other really good ideas, but those are my initial thoughts.
I mean, the philosophy of this design is it should be reliable, and so we have to design it so it doesn't fail. That's the bottom line.
And I can just follow up just briefly. I think probably from a monitoring standpoint, the real-time device, because of its portability and its ability to give you the metrics that are required for compliance, you'll need something like that, if not that. And they're portable, and you can get multiple units, and that would cover your bases and provide you the feedback that you need to ensure that the mitigation is occurring.
And after we do a few projects, our sample size will be dramatically larger, and then we can all prove to ourselves that this is a reliable system.
I got one more. The question is gonna come up about the PDA analysis is critical. In the next test plan, are you planning to do the PDA on a pile, a normal pile, and then this pile, so you really have some correlation?
take that.
Question is, are we going to do some PDA testing during the next test?
The answer is yes. I mean, we did it for the Tacoma test, and so we're going through the calculations right now, and we're definitely planning to do it for the Vashon test.
Yeah, so we actually did acquire strain and accelerometer data using a standard off-the-shelf PDA system, which was applied to the piles by an engineer from GRL Engineers. And I'm currently going through that data and applying the wave equation to it to come up with the pile capacity. As mentioned in my slide, you can't use the run-of-the-mill CAPWAP analysis yet because that's designed for a single wall pile. So I'm doing the calculations for the double wall pile now, and then we'll have to make that alteration to CAPWAP eventually.
Yeah.
So are the double wall piles, would they be analyzed individually? Like,
No, they're analyzed as a system.
okay. But you would have strain gauges on both of them?
We did, yes. We had a set of sensors, a set being one accelerometer and one strain gauge. We had those at the top of the inner pile on opposing surfaces and at the top of the outer pile on opposing surfaces.
Yeah, I'm just curious, was there significant difference in the inner and outer piles for their
In
capacities?
the amount of strain seen in the two piles, yes, and that's by design. That's why we have the load going through a spring so that the steepness or the strain rate that the outer pile sees is reduced, because we know that strain rate in that pile is proportional to SPL, or peak sound pressure level.
Yeah, sure.
In terms of the question that came before related to the integrity of the outer pile, one simple way to go is use your PDA with your follower or your inner pipe removed and bang on it and look at the waves. And that's the way we do it in regular practice.
That would certainly work.
Okay, got several questions for agencies here. Should I put you on the spot again, John? The zone of influence decreased about 90% in this test. What would it take to expand the fish window or the in-water work window? That's the spot.
That's a tricky one.
Oh, here, let me give you the mic. Yeah. Yeah.
Okay, so the in-water work window is more than just about noise. So there are things that you could get adjustments maybe on a project-by-project basis. I mean, I'm not going to, set any NOAA fisheries policies today. But, and that zone did decrease a lot. I mean, it's incredible how much, a 17 dB reduction in the SEL is going to shrink that zone of effect. But it also depends on how many times you strike the pile, what size the pile is, what the sound levels are coming off that pile, which could be different for larger piles or smaller piles. We don't know any of that quite yet. So, I don't think changing the fish window is going to happen because of pile driving, because it's also there for dredging, for for anything that's going on in the water. The fish window comes into play. So it wouldn't affect the fish window, but there could be some changes depending on the type of project, and as we get more information on it, where we could perhaps allow some pile driving to occur during times when we really wouldn't have wanted it before. But we need more data before we could get to make those kind of decisions, and those obviously would be made by somebody. And my arm's not long enough to reach how far above me they'd have to be.
Kind of a question in the same vein coming in from HDR. If somebody had a project and they wanted to use these piles, would you facilitate a streamlined permitting process just to sort of support gathering more data around this?
I mean, like at this stage of it, so somebody came up and said, hey, we'll do it next, well, in August when the fish window opens, because I just explained why we wouldn't change the fish window, but possibly. It'd be worth talking to us. We're obviously very interested in this kind of technology, and it's better to find ways to reduce the noise than argue about, how many fish are being injured or not. And I'd say possibly.
As long as John has the mic, does anyone else have a question for him? No? Okay. Another question that came in, this is from New Jersey, Fisherman's Energy. With the special shoe being so large, you're apt to increase tip bearing much higher than with a normal pile and typical driving shoe. Please comment.
That's true. We have more surface area that's going to be applied in a bearing situation to the soil. So this double pile will have greater bearing capacity, at least at the pile soil interface.
Okay. Other questions? Yes.
I think on the theoretical side would be for Tim, and on the practical probably for Bradley, but for a lot of general contractors, a lot of our pile we drive is temper for false work, reaction pile for oscillators, work bridge, things of that nature. So if they're going on to test this and kind of talking about how that the coupler takes the energy down, when that pile has been sitting out there on a work bridge, say for 6 months or a year, or the oscillator, and it's set up pretty well, and you're trying now to come out and pull that out, and you're typically relying on the vibro to go through and kind of wake it up, and then be able to get it out of there, and we sometimes have a heck of a time getting that to happen. So as we're trying now to relay that force out to the outer pile to help pull that, do you, Tim or Bradley, think that we're going to see a huge increase in the force being able to do that, or can you pull the outer one out and have it travel through the coupler and drag the inside one with it?
So the question is, given that a lot of pile driving is temporary or false work, do the panelists foresee any greater challenge lifting the pile up out when the time comes?
And this is kind of with the knowledge that you're going to 150, 200-ton driving.
Sounds like it's going to be tougher. Yeah.
So what
It
we
will be.
Yeah.
The question about whether you can grab the outside and pull the inside is, yeah, you can. It's going to be complicated because you have to cut the inner in stages so that you have access. But you only need, I don't know, it's about 16 inches maybe to grab the outer pile. So the inner would have to be that clear. So a guy could reach down in there. Of course, maybe in Alaska you don't want to do that, but here it'd probably be okay.
The other thing that we learned while extracting the double pile is that it was a really good thing to learn. When we want to pull these, we need to put some kind of temporary fixture to positively connect the inner pile and the outer pile. Bradley, do you remember when we hooked the inner pile and started to vibe it, and it would come up, but a lot of energy was just shaking that inner pile before the outer pipe came out, and it dawned on us like, well, why didn't we just weld a couple studs together so that outer pipe and inner pipe are joined during the extraction process? And that would have largely simplified that solution. So that was a really good thing that we learned.
Depending on, how far you have that pile in there, that weldment might be significant.
Yeah.
So.
Okay. There was a question about whether the entire test on video would be available. So that is on the website, the www.marinecontact.com, sped up, obviously, which will be a little bit easier. So that's there now if you'd like to take a look at it. This is a question from New Jersey again. If you drive with a mandrel with an open end and remove the mandrel after installation, your soil plug will not be bearing against the outer pile. Please comment.
That's true. Majority of that soil plug is going to fall out of the end of the mandrel and end up still inside of the pile. So now it's going to be a different, less consolidated soil than it would be if it was a compacted plug. I think we can all imagine that. But you're going to lose some soil with the mandrel when you pull it up, and you can see that when you view the video online. You'll notice that some soil has adhered. But these are, at least what we're working with now, are relatively large diameter piles, and soil plugging is not real prevalent, at least what we've seen thus far.
Any more questions? Okay. I don't understand that question. Oh, yes.
Couple questions at Vashon Island. Number one, are you gonna be able to drive for bearing there? And number two, are you anticipating driving with the vibratory hammer so you can get some comparative documentation?
So the question about the Vashon Island test, are we going to measure using a vibratory hammer so we can get some comparative data? And are we going to drive to Bering there?
Maybe Jerry can comment on that.
Introduce yourself. Thanks.
I'm Jerry Bernstein. I'm with Washington State Ferries, and our plan is, because the piles are 80 feet long, that we'll be driving them into really dense soil for 40 feet. And these are just test piles. And so hopefully the PDA and the WEEP analysis will be able to tell us what the capacity is at that time. And we hadn't really, and we had just said we were going to be impacting those piles at this time in the permit. So, but if there was an advantage to vibrate instead, then that could be something that we could think about, perhaps. So.
I have a comment about vibing also. There are times when it's a matter of weight that you vibe part of your piling. When you get into giant sections, the equipment that's required to impact them is enormous. And so you don't necessarily always have a full-length setup to do that. You vibe part of it, and then you impact there at the end. So there's going to be a point where, you know, they have to be looked at and balance out.
Okay. Final comments from panelists?
Thanks for attending.
We enjoyed it.
Yeah, thank you very much. All right. Please complete your surveys if you would.